All right, so I want to look at just a couple of the problems. These are actually, I think, in your reading, but thought I would kind of run through these anyway. So the big idea here is the definite integral is just the area under a curve down to the x-axis. Technically, if your graph runs under the x-axis, it could be the area from the graph up to the x-axis as well. But I think all the examples we're going to be working with right now are going to have positive function values. By the way they write this, so they give you the function 8 times 0.7 to the x. Technically, the symbol for a definite integral looks like a kind of an S symbol. And you say the integral of 8 times 0.7 to the x. Technically, we put a little dx there, which has some kind of meaning, but you don't have to worry about it for right now. And we say we're taking the integral from 1 to 7. And all that means is I have the function 8 times 0.7 to the x power, and I want to find the area under that curve between an x value of 1 and an x value of 7, okay? Anyway, for right now, we don't really have anything sophisticated. We're really just counting squares for the most part. You need to come up with a system that works for you. I usually write numbers in, so I'll say like, oh, I've got 1, 2, 3, 4. This is easier with the pencil, 5, and so on. And then you just kind of add them up. Now, one like that might be maybe about a 0.6. One like this might be about a 0.3. One like that might be about a 0.3. And I just kind of add everything up there. And anyway, I'm not exactly sure what the estimate would be on this one, but you're just adding up squares. And you're going to get an estimate. You're going to get a decimal probably, since you have a lot of partial squares under there. And that's really all you're doing for the moment. Okay. Now, to come look at a few other examples here. Here's a problem. It's a velocity function. Again, remember the area under the curve in a time interval for velocity will give you the distance traveled, or if we can get really technical about it, the displacement, but we don't have negative velocities right now, so we don't really have to worry about that. And so you can see in this example here, they want to know how far, if you were traveling at this velocity, how far you would travel between, it looks like t equals 0.1 and the time equals 1. And again, you can just kind of add up these squares here. By the way, you need to be careful. A lot of times the squares are not 1 by 1s, okay? And if you notice here in this diagram, those are each a 0.1 by 10, okay? So if you have a bunch of rectangles that are 0.1 by 10, they look like squares, but they're really a 10th by 10. Oh, is that? It's a 0.1 by 10, I don't think. I think it's a 0.1 by 5. Let's go back and look at that again. Yeah, it's a 0.1 by 2. I'm sorry, they're 0.1 by 2 rectangles there. And so anyway, if it's 0.1 by 2, the area of each of those is 0.2, not 1 square unit. Okay, and so if we go back and we look at their solution here, you'll notice they say the total distance traveled was about 23.8. Okay, they're actually a little over 119 squares. I'm not going to ask you to add up that many squares in most of these problems, but you have to be careful. Each of those little squares, or each of those blocks, if you want to think of it that way, only had an area of 0.2. So we have 119 blocks with an area of 0.2 each. Multiply that together, you get 23.8. Notice here you're taking feet per second, and when you're finding your area, you're multiplying it by seconds. And so that's going to give you a final unit that's just feet. Remember, when you're finding definite integrals, you're multiplying your units together. And that is something that I'm going to look at a little bit more careful in another video if you're having trouble finding units. But anyway, that's the basic idea. Counting blocks, just be careful. If they're not 1 by 1s, make sure you know the areas of each block before you find your final answer.